Now that we know that there are 2 pi radians and 360 degrees, we can name our special angles as fractions of pi. So we have 360 degrees is equal to 2 pi. So here's 0 radians, and as we come back all the way around the circle, we get to 2 pi radians. Half of 360 is 180. So that means 180 is going to be pi radians. Half of 180 is 90. So 90 is 1/2 of pi, or as we more typically call it, pi over 2. So this is pi over 2 radians. So this is these are important ones to remember. 180 is pi, 90 is pi over 2. Now what about 270? Well, 270 is 3 times 90, because 3 times 9 is 27. So that means it's 3 times pi over 2, or 3 pi over 2. So our fourth big angle is 3 pi over 2. So those are the big angles, 0, 90, 180, 270. Okay, let's take a look now at 45-degree angles. Now 45 is 1/2 of 90, or 1/2 of pi over 2, which is 1/2 times pi over 2 is pi over 4. So pi over 4 is equal to 45 degrees. And that's our first big one that we know for special angles. Now the best way to get to the other angles is just to count 45-degree angles around the circle. So we have 1 45-degree angle, 2 45-degree angles, 3, 4, 5, 6, 7, 8. Now we've already named 90, 180, 270, and 360. So this would be, for example, 2 pi over 2, which is pi over 2. So the next big one that we haven't named yet is 3 pi over, this would be 2 pi over 4, which is pi over 2. So then 3 pi over 4. 4 pi over 4, of course, would be pi. 5, the next one would be 5 pi over 4. 6 pi over 4 would be the same as 3 pi over 2. Then we would get to 7 pi over 4. And then the last one would be 8 pi over 4, which would be the same as 2 pi. So I just want to write down a couple of those just to show you. So this would be 2 pi over 4, which is the same as pi over 2. This would be 4 pi over 4, which would be the same as pi. This would be 6 pi over 4, which would be the same as 3 pi over 2. We're just reducing the fraction. This would be 8 pi over 4, which would be the same as 2 pi. So the special angles that are 45-degree reference angles, so if we go back and look at this, 45, 45, 45, 45, all of these have 45-degree reference angles. Notice that the numerators are odd numbers and the denominators are all 4. Numerators are odd multiples of pi and the denominators equal 4. And these are just ways to help you remember those special angles. I'm going to go ahead and put a box around these two because these are our big important 5 key points, like 0, 90, 180, 270, and 360 have been. Now we're going to do this in terms of pi. Okay, now we're ready for our 60-degree angles. So our 60-degree angle, what we have to recognize is that 60 degrees is 180 divided by 3, because 18 divided by 3 is 6, 180 divided by 3 is 60. Since 180 is equivalent to pi radians, this would be pi over 3. So pi over 3 equals 60. Okay, that's our big one right there. Now, we could do the same thing as we did with the 45-degree angles and just count how many 60-degree angles there are around the unit circle. Because this would be 60, and this is 60, but of course since the whole thing is 180, that would also be a 60-degree angle there. So these are 60-degree reference angles, but also dividing into 6 60-degree angles. So we have pi over 3, 2 pi over 3, 3 pi over 3. So I'm going to go ahead and label these 2 pi over 3. 3 pi over 3 just equals pi. 4 pi over 3, 5 pi over 3, and then of course 6 pi over 3 is equal to 2 pi. So our big angles here are the 2 pi over 3, 4 pi over 3, 5 pi over 3. Now if counting around the circle doesn't appeal to you, there's another way to look at this. I could also think, okay, I want to know what 120 degrees is in radians. So I can think of 120 degrees as 2 times 60, which means it's 2 times pi over 3, or 2 pi over 3. I could think of 240, 24 times is 4 times 6, so this would be 4 times 60, or 4 pi over 3. And 300, I'm not sure if I can fit this on here, 300 is 5 times 60, which equals 5 pi over 3. So we're just multiplying pi over 3 times different whole numbers to make it, because these are all multiples of 60. Okay, our last batch now are our 60-degree special angle, or sorry, 30-degree special angles. So once again, we can say that 30 degrees is 180 divided by 6, or pi over 6. So our smallest 30-degree reference angle is in the first quadrant. 30 degrees is pi over 6. So that's a key one to remember. Then our next 30-degree angles is 150. So this one I think is easier to think of it as just a multiple of 30. So 150 is 5 times 30, which would then be 5 pi over 6. Then the next special angle in quadrant 3 is 210. So 210, 3 times 21, or 3 times 7 is 21. So 7 times 30 is 210. So this is 7 pi over 6. The last one in quadrant 4 that has a 30-degree reference angle is 330. 33 is 11 times 3, so 330 is 11 times 30, or 11 pi over 6. So this is 11 pi over 6. So these are our 30-degree reference angles, are all multiples of pi over 6. Now notice I could do 60 is 2 times 30, which would be 2 pi over 6, but 2 pi over 6 would reduce to pi over 3. And 90 would be 3 times 30, or 3 pi over 6 would be the same as pi over 2. So I'm not going to put in all those extra ones, but I do want to show you one thing. If I did 6 pi over 6, of course that would equal pi at 180. Or if I did 12 pi over 6, that would equal 2 pi at 360 degrees. Notice that if I take 6 pi over 6 and just subtract 1/6, I get 5 pi over 6, and add 1/6, I get 7 pi over 6. If I take 12 pi over 6 and subtract 1, I get 11 pi over 6. Obviously, pi over 6 is just adding 1 to 0. The same thing happens with the 60s. 3 pi over 3 minus 1 is 2 pi over 3, plus 1 is 4 pi over 3. 6 pi over 3 minus 1 is 5 pi over 3. So we could also look at these as just one away from a whole pi, or 2 whole pi. So those are all of our special angles and radians. Notice that the 60-degree angles have 3 in the denominator, and the 30-degree reference angles have 6 in the denominator when you put them in terms of pi. The 45 have 4 in the denominator. That's important to remember.